Besides using Riemann sums and trapezoids to approximate the area under the curve, one thing that we also want to take a look at is, well, this approximation that we found, is it an overestimate or is it an underestimate? And we can actually determine this by looking at how the function is changing and how the function is curved. So this is a little discovery that I'd like you to try on your own. I'm going to help you set it up, and then I'm going to ask you to pause the video and see if you can answer the questions with a little bit of drawing on your own, and then unpause the video and see how you did overall. Okay. So for starters, here's what we're looking to do, and you can see this in the first bullet point in the notes there. Can you create 4 separate graphs? In the first graph, we're looking for a function which is increasing and concave up. In the second graph, we're talking about increasing and concave down. In the third graph, we're now decreasing but concave up. And then for our last graph, decreasing and concave down. Okay, so you're going to make those 4 graphs, and I would suggest doing that in pen. And then switching over to pencil, because you're going to do some erasing. Now we're going to start to put in some rectangles and some trapezoids, and actually a couple of tangent lines as well. Right. So for the first one, you see there, the second bullet point says, under what circumstances will a left-hand sum be an under approximation? Well, these are the 4 different types of curves that we could have going on: increasing and decreasing, concave up, concave down, split up accordingly. So let's make some rectangles in which the upper left-hand corner of each rectangle touches the curve. So if we were to do that for each of these 4 situations, right, and 1 or 2 or 3 rectangles should be plenty to see what's going on. Again, all we're doing is we're just creating rectangles in which the upper left-hand corner of the rectangle is touching the curve, like so. And as you're doing these, okay, now that we've got these left rectangles ready to go, take a look at the data and determine what does the function need to be doing, or how does the function need to be changing, how does the function need to be shaped, potentially, in order for us to determine when a left Riemann sum is going to be an under approximation, when it's not going to get all of the area under the curve. Right? And then take a look, I think you actually got to jump down to bullet point number 4, when is the left sum going to be an over approximation? Okay. And then erase your rectangles, put in some right rectangles where the upper right corner of the rectangle touches the curve, and see what happens in that regard. When is the right sum going to be an over and under estimate? Okay. Then erase those and put in some trapezoids and determine when a trapezoid approximation is going to be an overestimate or an underestimate. And finally, draw some tangent lines like so. And based off of the tangent lines that you draw, determine when those tangent lines are going to be over and under approximations. At some point on the exam, they're going to ask you whether your approximation is an overestimate or an underestimate, and this activity should help you get things squared away. So at this point, pause the video, use your pencil, make all your drawings, come up with some conclusions, and then unpause the video and see how you did. So you can see over my right shoulder here, a left sum is an under approximation when the function is increasing, but an over approximation when the function is decreasing. A right sum is the inverse of that. It's an under approximation when the function is decreasing and an over approximation when the function is increasing. Trapezoid approximations, doesn't matter whether or not the function is increasing or decreasing. What matters is the curvature of the function. If the function is concave down, the trapezoid sum will be an under approximation because there's going to be a little bit of space in between the top of the trapezoid and the curve. If the function is concave up, then the trapezoid function will be approximation will be an overestimate. And finally, with the tangent lines, it's the reverse of the trapezoids, okay? Because the tangent lines will fall underneath a concave up curve, but they will be above a concave down curve. So if you're using a tangent line to approximate the value of the function, which we did way back when we started learning about all of our rules for differentiation, and it's going to come back again as we start to see some sample AP questions, you're going to see here that the tangent line is an under approximation, concave up, over approximation, concave down. So here are all your approximations, and whether they are overestimates or underestimates. These you want to be ready to go with on the exam. There will be a question that's going to test your skill on it.